Next up is Pete Bommarito. Pete is the owner and president of Bommarito Performance Systems, also the owner and president of Bommarito University. He's an adjunct professor at Nova Southeastern University in the exercise science department, also a partner and director of performance at Perfect Competition Athletic Development. Pete received his master's in exercise science with a specialization in sports biomechanics at Ball State University, and his BS in biology and pre-medicine from Missouri State University. I think those of us that have been in the game long enough have had a player to train at Pete's facilities. He's one of the leaders in the industry when it comes to sports performance facilities in this country, if not worldwide. Pete will be presenting on. He'll be presenting on using the Proteus 2.0 technology with post-activation potentiation protocols in the weight room for various Major League Baseball weight room phases. Pete, go ahead, take it away.
All right, thank you. You can hear me okay? Everything good? Frank, we're good?
Yes, yep, I can hear you. We see your screen and you're all set.
Okay, perfect. Okay, yeah, so we're definitely going to be discussing a lot on velocity-based training and advanced technology. And one of the technology that Frank mentioned is we're going to be discussing the Proteus 2.0 biomechanical system. And I think the main thing is when you look at the different biometrics of how to get velocity-based training and add an additional technology, especially some of the advanced technology that I think at one point was noted as stuff we do in beginning evaluations or in a lab. Now we're able to move it within an actual live weight room session. And the key is, I think, the quantification of the post-activation potentiation. And then I'm just going to be discussing various weight room phases where this really, kind of comes into play. Okay. So first off is just kind of just going through a brief synopsis of the technology that I'm going to be discussing here. So definitely, yes, we're going to be discussing the Proteus 2.0 and how this is utilized, not just on the evaluation side, but within live training with groups that's still easy to implement for strength and conditioning coaches without interrupting the flow of the group, but being able to customize each individual. For the velocity-based training, either of the bar device or the person, actually, we use the push system. In terms of the advanced external force plates, the one that we've used and had a lot of success with is the Vlad. Now, we do have some basic biometrics of just utilizing like the Just Jump Mat for RSI and beginning evaluations. And then with regards to somewhat of quantification of different types of rotational, diagonal, and push-pull power, the air resistance machine, which we have both the Flex Line and the Kaiser. And then we've got the High Trainer, which we actually use as a weightlifting tool, not necessarily as a treadmill. This is going to be some of the stuff that we've incorporated, had a lot of success with in the group setting with the weight room. And then we're looking at some specialty equipment. So some of this stuff can be quantified with the velocity-based training with something like the push system. But we also utilize it in terms of quantifying the PAP and utilizing some of the standards that might not quantify power, but you can quantify the PAP right before these standard-based power-based motions. So the belt squat that we use and then the safety bar that we use are as such, and I'm going to play some videos to kind of give the benefits of why we use this and why it's so important when we're trying to track this bar velocity, especially the open trap bar through Kabuki. And then we do have the jammer arms, which I think is pretty prevalent now in elite level baseball. The reason why we use the rack attach is because they're adjustable. We can do multiple band attached capabilities in terms of accelerating to the end range of motion. And in terms of the cable system, we just want to make sure, from our standpoint anyway, that the cable system has the ability to add the variable load, which we just use the Sornex on because it attaches the outside of our rack and gives us that band variable loading capability. And then the obvious ones is going to be things like the Vertimax resist assist, the landmines free band assist, and then the triphasic arms. So now just getting into the actual weight room phases. Okay. Now, what we're going to discuss, just because I have time constraints, obviously I only have an hour, so I'm not going to be able to go through the dozens of different types of weight room phases we might do in the early, middle, or later off season, or even in season. Okay. We're going to focus on the conjugate because I think that's where these quantifications matter the most. Okay. So our standard of the meat of the off season, meaning that we've already went through the beginning phases, we are now ready to try to accentuate max power. It's set up as 4 days of lifting. Now, keep in mind, we're obviously going to individualize this as we get into our peak before spring training. And definitely, if we're looking at anything from a conjugate undulating system in season, we'll modify this down. But I'm just going to be focusing on the most aggressive conjugate we have at 4 days of lifting, with the understanding that this could easily be quantified down to 3, 2, or on an undulating in-season phase if need be. So if you look at the most aggressive conjugate phase that we can get into that is specific to elite baseball, we're looking at a 4-day split. Day one is typically upper moderate to max effort. And I say moderate effort because depending on what exercises we're classifying, there's only so much max effort work we can do. Lower body squat, hinge, of course. Upper body press, not a chance. In terms of the second day, the lower dynamic. Now, this is where we're going to start to use the force plate data. And I'm not talking about the simplistic things like the just jump mat. Those things are great. But I think a key question a lot of people ask me is the advanced force plates that are external, meaning they can be moved around. You definitely see them in biomechanical labs, which we have. We definitely have them inside of our medical recovery regeneration center because our physical therapists, for example, are really going to base a lot of their medical work based on force plate data. What we've done is we've started incorporating this, not just with beginning evals in the medical room and as a preset, we're putting it into live weight room sessions. I'm going to kind of discuss how we do that. And then in addition to tracking the force plate data consistently throughout the weight room phase, we add in what we call quantified rotation, which could be extremely advanced using something like the Proteus, or fairly simplistic, which a lot of people are familiar with regards to the air-resisted flex line and the Kaiser that kind of tracks those things. But keep in mind, when I say rotation, that's just one simple aspect. We also are going to be looking at different types of diagonal patterns and different types of press pull patterns. And in addition, we could look at different types of glenohumeral rotation at various aspects. Number 3, we get to the upper dynamic. This is day 3. This is probably the biggest challenge because in a typical conjugate for a non-overhead athlete, you're going to be doing things like speed pressing. Now, we will not do that with the standards of bar with regards to baseball players, but there is dynamic motions of an energy transfer that can end with some type of a dynamic elbow extension. It's just got to be modified, obviously, for the health reasons of an overhead athlete. That's why I'm talking about the dynamic is really based off energy transfer. Now, we do dynamic posterior chain work upper body, but it's got to be modified to each individual. Just because it's a pull and it's dynamic doesn't mean it's always appropriate for baseball. And we'll get into some of those metrics. And then the day 4 is the lower body where we go moderate to max effort again. We'll get a little bit more aggressive with towards that near max effort lifting, especially on hinge patterns with baseball, which is a little bit of a contrast to day 1 upper. Okay. And then as you see, day 2 lower dynamic, we're looking at quantified rotation. Day 4 is when we still kind of hit the quantified rotation along with the force plate data that also is going to track these diagonal patterns. Okay. Now, I have to preface this by stating the obvious. Everything that I'm going to show, I don't want people leaving here thinking, okay, that's extremely aggressive. And how do we know even if an elite level baseball player can handle those loads? So we are going to have an understanding that the exercises that I'm going to show that is specific to an aggressive conjugate phase has to be built into. This is some general points of how we're going to build into that. Now, again, because I only have about an hour, I can't go extensively through a general preparatory or intensification phase. It's just understood, which most people here are going to understand this, where once we get somebody in after the recovery medical realignment period, after a season, we will definitely go into a general preparatory phase. We still heavily incorporate the medical side, which is the physical therapists, the athletic trainers, chiropractors, neuromuscular therapists, massage therapists, really focusing on the joint realignment, which I'll explain when we get into the videos. Definitely, we call like the intro to deceleration. We're going on the deceleration patterns, just slowing the tempo down, and definitely overloading trunk and spine symmetry. And what we like to do is primarily via isometrics, which again, I'm going to have video demos of this. So I think when we talk about trunk and spine symmetry, we definitely look at the fact that, you know, baseball is a one-sided sport. You know, you throw from one side, and even if you're a switch hitter, you predominantly are rotating and doing those diagonal patterns from one side. So there's always going to be some asymmetry when it comes to certain range of motion of joints. What we say by symmetry is trying to drive the trunk and spine towards symmetry, primarily spinal rotation and spinal lateral flexion, especially at the transitional vertebrae, trying to make sure that it's not just the range of motion, it's the quality of motion, and most importantly, stability at the end range of motion is quantified and set from a medical standpoint, symmetrical, prior to even getting into the intensification phase that will eventually lead into the conjugate phase I'm going to be discussing. Now, when we get into the intensification phase, this is definitely more focused on the loaded eccentrics. And that's when we start getting into identifying when joints come into an alignment from the medical standpoint into the deceleration. So at my facility, we have all of our medical centers, recovery, regeneration centers, all the therapists are in rooms connected to the weight room. So it's really like a back and forth thing where we believe in lifting safely in an aligned state and executing max power ability in an aligned state. So it's almost like even if a player is not injured, they're coming right off the medical table into the weight room, and we're taking the medical reports and then individualizing the scripts a little bit further. And this is where we're going to start getting into integration, which again, I've got videos of. Okay, so this is a broad overview of what we're going to find prior to the conjugate phase that I just described, along with the videos that we're going to show that relates to these conjugate phases more. Now, keep in mind that when you're looking at volume, this is definitely dependent. You know, I'd say for the general preparatory phase, when somebody comes in early in the off season, right after a season or right after instructs or fall ball, if that's appropriate for them, you know, on average 1 to 3 weeks. But keep in mind, we've had people in general preparatory phase a lot longer than 3 weeks if they have some type of an injury that they didn't even have surgery for, but still has to be addressed. And typically when you get into these eccentric focuses, yeah, it could be anywhere between 2 and 3 weeks. Okay. So we're going to go into the next video sequence and that advanced conjugate phase with the understanding that we have adequately got through the GPP and had good success through the intensification. Along with this is daily medical evals, treatments, and reports. And once we kind of get the green light from the medical staff that we are symmetrical enough to hit a safe aggressive conjugate phase, that is when we get into those parameters. So again, the phases leading into is as shown here. Now, this is kind of an overview of what the first 2 days might look like. Now, keep in mind that this is just one phase we wrote for one particular athlete, but at least it gives a common theme. Okay. You see the day one is as such here. And the day one is typically like we call the upper moderate to max effort work. Every time you see a 1 and a 2, that to us is a complex, meaning that we're going to hit our heavy single arm row immediately followed by an auxiliary row. And then we take about 2 to 3 minutes rest. And when you see this indentation here with the corrective, that means we have a corrective exercise that is assigned by the medical staff that is specific to this individual, that is going to help overall the quality of contraction during the row and preceding into the next complex, which is our heavy pressing and our cable or Proteus or flex line or whatever lift. Okay. So we just believe, because we have the same time constraints that every strength coach is saddled with, to be productive during the rest period. So this corrective could be down in the foot, it could be in the pelvis, whatever the asymmetry that they're driving towards, and we enter into the conjugate phase. We can't just say, okay, they're aligned, let's go conjugate and go. We have still got to raise the threshold of some of those big deficiencies that they were treating, even if the deficiency is minimal, hence why we're in the conjugate phase. It still has to be implemented, in my opinion, because it keeps the threshold of force application high. So really you see that kind of that common theme where you see a press immediately followed by a quantified diagonal motion that can be explosive with a rest period of 2 minutes. But during the rest period, we are hitting corrective work assigned by the medical team to continue to enhance the threshold for each successive set. Okay. Now the key point is really focusing on day two. Day two is the lower dynamic. Now, what we will do, this is where we start to integrate the force plate data. So I'll show videos in terms of how we set the weight room up. But if we look at even our dynamic days, we will complex it, driving towards post-activation potentiation. Now, in standard research, you're looking at PAP of a max effort load into a power, which we will do on day 4. But we also have success if we can get to a double leg squat or hinge pattern and add significant variable load, tracking bar speed. We can still have that neurological effect of that PAP, leading us into something that is explosive. So we don't want to guess. We want to track how the PAP is working. So we will hit one set of something like a speed belt box squat with either a 1-1x tempo or an x1x tempo. And side note quick, our tempos are always eccentric, isometric, concentric. So if you see a x1x tempo, it is a speed dive bomb squat down, catching it right before the box, tight trunk isometric hold on the box, then the X is explosive back up. With the addition of the chains and bands for the variable load, we can safely accelerate through the end range of motion, even with something like this belt squat. Okay. Now, the theory is that when we do this, we are eliciting the motor unit recruitment and heightening the nervous system. But I don't want to just guess based on research. We will immediately put them on the force plate, do at least one vertical jump, track the data. The data instantaneously goes in the online account, and then we can compare it to set to set from the conjugate phase from the previous intensification phase. And I think most importantly, the same force plate data that we are constantly tracking at the end of our medical treatments. So if the nervous system is going up, we can see not only an increase in these biometrics, we can also see symmetry because our VLAD external force plate system has a foot on each force plate, and we can look at symmetry. So as this is driving up, we are now quantifying the effect of PAP before we get into a power-based motion, which assigned here is like, for example, a Proteus 2.0 split stance mid-rotation. Okay, so we'll hit 2 sets of speed box squat force plate, 60 seconds rest. Speed box squat force plate, 60 seconds rest. Immediately going into the Proteus, and the Proteus itself will quantify rotation. So not only are we tracking bar speed on the dynamic workout, we're tracking PAP between the dynamic work and the Proteus dynamic work, and we're quantifying rotation or diagonal in a sense. So to us, when we start getting these biometrics and all this stuff is immediately uploaded into the cloud for that athlete, even if we're in a busy weight room and we can't track it immediately, we can at least look at the number. make sure PAP is going up, hence the assigned volume and intensity. So we don't want to just assign 12 sets. That's like a baseline. If the nervous system is down more than expected, we drop the sets or drop the intensity or both. If the nervous system is continued in a heightened state that's better than we expect, which we hope, we can continue to add more volume and or more variable load based on these biometrics. Okay. And then you obviously see some basic auxiliary work here. Okay. Day 3, day 4 follows a similar pattern. So day 3, this is a sample of what an upper body dynamic day would be. Keep in mind, what you don't see is the standard conjugate variable loading explosive pressing. But when you get into band jammer rotations, which I'm going to show, when you get into things like that, it's an energy transfer ending with a modified press that is safer for an overhead athlete that has a lot of those stress factors during the actual sport. Okay. And then when you see the lower max, this is typically right here what most people consider when they're looking at the post-activation potentiation they see in literature and research, okay, which is a heavy loaded squat or hinge immediately followed by an explosive motion. But again, we track the data. We'll even take some of these single leg squats, double leg squats or hinge and still track bar speed, even though our goal isn't an assigned bar speed of, let's say, 1.0 meters per second, like you saw on the dynamic day. But we'll still track bar speed, still get the force plate data to track symmetry and that PAP effect, and then get into an explosive motion, which we still could be the standards of a box jump or vertical power. It could be the standards of a loaded box jump of loaded vertical power. It could be any plyometric or assist resist effect. But if we're really trying to get towards baseball specificity at this point, this is where we can start implementing the band jammer, the air resistance, and or the Proteus, which is high quantification. So we're still tracking PAP and still quantifying those overhead or baseball swinging specific explosive motions. Okay. And then you see some standard auxiliary work post. So now let's just get into some of the videos. This here is the Proteus 2.0 for those of you that are not familiar with it. The reason why we like this system is because not only does it give us great biometrical data on a beginning evaluation of every possible rotational pattern, left, right, diagonal pattern, left, right, high, low, and different types of press, pull, and side to side lower body, up, down, lower body, and even gets into various stages of glenohumeral rotation at various joint angles. Okay. So we like it because it gives us real-time data of segmental body positions. And most importantly, when we're looking at that left-right symmetry. But what we'll do is we'll actually incorporate it into the weight room sessions. So here's a basic mid-rotation series. Okay. As you can see, the main difference of this versus an air resistance, which you see like the flex line in the background here and the Kaiser in the background here, is you are being concentrically resisted to both sides during the exercise. So if you look at this, the key aspect of all this is when you're going rotation left, it's concentric. You're going concentric, or you're going rotation right, it's concentric. If we were doing a pattern like this on the flex line, it would be dynamic concentric, and then it would go back in the machine eccentric. Now, concentric eccentric is good, but we've got to make sure that sometimes you can get the concentric action 360 degrees around the body. Now, continuing on, we've just got different styles of rotation. This is a standard standing mid-rotation. Here it is in slow motion. Standard standing mid-rotation. Okay, but the good thing is we can get this quantification into different split positions you see here. So a different challenge of stabilizing that pelvis with split positions of the same mid rotation that again is concentric to both sides. Now you really have a good idea of the split stance. And by the way, this is where you get the biometrics right here. So the athlete comes in, switches the phone, it pops up online so you can see it, and then it goes into the cloud on the client's account. But at the same time, it's giving you the digital readout, left-right symmetry, as we're training live during a weight room session in the middle of this conjugate phase, okay? So this is mid-rotation split stance. Here's a side view, same thing, mid-rotation split stance. And we can also go half kneeling supported, which you see here, or imagine if the knees 1 inch off the ground, that's half kneeling unsupported. So again, the key is you can get different styles of what we're doing with rotation. You see here, the main thing is look at the pelvic torque. This aligned pattern of half kneeling focuses on the adductor contraction isometrically that stabilizes the lumbopelvic region. And what does it do? It places a lot more rotational forces at the transitional vertebrae of that trunk rotation. But even though we're in a right leg or a left leg half kneeling split position, we're still getting that concentric data left to right, which is really, really a key aspect of this entire operation. Okay. Now we can get into the diagonal series. Again, as you see here, we can go high to low. Now, whether we're facing the machine or in a machine stance like this, it still is going resisted in, resisted out, resisted up, resisted down, resisted side to side. The Proteus is 360 degrees around the body. And as we're adding this into that conjugate phase, keep in mind, we're tracking left-right symmetry as we go during the same motion of facing both ways. Okay, now we're getting into the half kneeling supported diagonal motion. This is a slow motion here. Diagonal up, explode, diagonal down, explode. So we're going concentric down, concentric up with this diagonal pattern in that split pelvis position. Or this is just some baselines. We do sometimes we go the chop and the lift diagonal pattern together. We'll do different circular patterns in terms of clockwise, counterclockwise, everything concentric, pressing in, pulling out. Now, sometimes we will do dynamic presses depending on the athlete, depending on the side of throwing or not, or we might go slow press, fast pull, just looking at any of the motions. But the good thing is we decide to do a dynamic press eval and system, it's resisted in, resisted out, which I think is a key component. Okay, now let's go through some non-quantified standards and simplistic quantified standards. We still have a lot of the same systems in addition to the Proteus that we will put on those number 2 complexes of those conjugate phases that we discussed. All right, this is the adjustable jammer. So I like the fact that we can variable load it from any aspect on this rack. And if you look here, similar pattern, but we're looking at explosive out with the slow 4-second eccentric back. This is getting into what we talked about of a modified dynamic press specific to baseball. Because if you look, we are still looking at some energy transfer from either the lower body or the pelvic torque with the explosive part of the dynamic elbow extension without that barbell explosive press. Because of the variable load, here it is in slow motion, you see it's got about a 3 to 4 second eccentric, explode out, and sometimes we'll hold that for maybe a 1 to 2 to possibly up into a 4-second isometric at the end, really focusing on that. Then you can get just a little bit more specificity here. So if you look at this one, it is raising the front foot, really focusing on the pelvic torque with the back leg rotation, and then finishing single arm just for the stabilization effect. Okay, so torque, once you explode through the elbow extension, holding either an isometric or as you see here, a very, very slow eccentric. So these aren't quantified, but keep in mind, if we put these at the tail end of that complex we showed, what are we doing right before this? We're doing that force plate data. So even though the rotation isn't quantified, it still is very effective because we are quantifying the post-activation potentiation effect by hitting the force plate right before these types of motions. Here you just see a standard reverse rotation on the adjustable arm that's variable loaded on that Sornex rack attached. Again, you see the slow 4-second eccentric, but look at the pelvic torque and look at the separation and the challenge and the intensity we put on the transitional vertebrae. Now, keep in mind, this is about as aggressive as it gets. This is not specific to a lot of athletes, but if we want to just get a little bit of a posterior chain rotation into some stability, it's a row into a basic press with very, very, very light bands and really focusing on the isometric at the end. So we don't think of this as like a snatch or anything resembling it. It's more of an explosive rotation, dipping a little bit and then coming up into the explosive. But keep in mind that this has got to be cleared medically across board before we get into it. This is more of a safer system of dynamic posterior chain work. Again, split position for the stabilization effect, but definitely high end on the explosive motion that, again, is quantified from the force plate data immediately before we get into this explosive motion. Okay. Now we can also look at possibility of pressing. Now we're not going to do this explosive. I like the variable load only because of the shoulder stabilization, which you see is still not in the overhead position. It's a slight overhead position because of the lean, and it really overemphasizes the trunk extensors. And then we just got some basics that we know we've already seen before, whether it's landmine, linear, lateral, or rotational work, simplistic forms of band chops or lifts. And then if we get into the standards, now we're moving into Kaiser or flex line or both air resistant. So this is a basic chop with the opposite leg up, focusing on hip horizontal adduction and different forms of hip rotation isometrically that is unique to this individual. Number one, because he's a pitcher, and number two, because not necessarily he's deficient at this time, but during the evaluations, that was definitely asymmetrical left to right, which you typically see in a lot of high power pitchers with extensive velocity, that was treated extensively during the GPP and the intensification phase. So as opposed to just assuming that it's fixed, we are constantly adding that diverging force, overloading that intention to keep the threshold up while he's doing that dynamic chop motion. So this is a favorite of ours of using during post-activation potentiation quantification for pitchers. So if a pitcher has a lower body dynamic or lower body max effort, or even an upper body max effort pull, we will bring the force plate data in between the primary exercise right before this explosive exercise, because we can simplistic quantify it on the energy and power counter on the air resistance Kaiser flex line and still be able to track how the PAP is affecting him left to right. Or if you want to go concentric on both sides of the chop or lift, you can do this exact same motion with the Proteus, which we have success at both. Now looking at from the chop you see here into just basic rotation. So we can take an explosive rotation and go through different segments. This is a high to low rotation. This is a dynamic row. Keep in mind that you get the eccentric, concentric. It's still good to train the eccentric, concentric power to get the digital readout. It just depends on exactly what we're looking at. So if you look at the lift pattern here, very, very similar to what you're going to see, what we saw earlier on the Kaiser. The flex line is just a little bit better option at this point because the flex line is a lot more durable, and you can quantify and change the resistance during the actual exercise because it comes with the handles that you can change by just a thumb press, or it comes with these bars that you can change by a finger press in the middle of the exercise. So this is concentric explosive energy transfer out, ending, or explosive concentric down. So again, as you can see, you can change the resistance during the exercise. It also will give you the constant air resistance so you can explode through the end range of motion of that right and left elbow extension after the energy transfer down. So concentric down, eccentric up, which is going to give a simplistic quantification of overall power. And then obviously the right-left symmetry is going to come into play because we're going to do this from both sides. So same pattern you can do either with air resistance, which you see the flex line here going up into an explosive chop, and do the different types of variable loading patterns or constant loading patterns you see here. Okay. Now, getting into the actual, how does it all fit together? Those are just videos now that's really focusing on how do you assign the number 2 right after the force plate. Now let's get into some of the work that we're going to do as the primary. We're going to start with lower body. This is that rogue belt squat we talked about, which we like because it's a perfect biomechanical position of pulling straight down. Now, this is just standard loaded max effort work. We like to do the box only because I like to have a strong brace at the bottom of a parallel squat position and be able to track the knees a lot more effectively. I like the lean forward arm action because you can really focus on the trunk bracing and that hip hinge motion. And the good thing is we get the dynamic work, which I'm going to show, you can easily add the chains and the bands underneath to get more dynamic acceleration to the end range of motion effect. Okay. So this is just a standard max effort, moderate effort load, or same kind of position here, just a different handle position. Now, this is where it gets dynamic. On this one, we're doing a 2 to 3 second eccentric, 1 second isometric with an X tempo on the concentric. Now, as you see here, we've got 4 chains loaded each side in addition to bands. So the intention is to accelerate through the end range of motion, still getting that PAP effect with this type of a dynamic squat, or this one here is the X1X tempo. So notice that we're dive bombing down, but at no time are we relaxing on the box. Okay. Or if they're just not comfortable or they want to have a different loading pattern, we can transfer into some axle loading. Now, if we axle load a professional baseball player, I would much prefer to use the safety bar. We use a transformer bar only because it's got these different link systems of getting into more of a front load versus somewhat of a hinge load. It's easy for us to transfer back and forth based on the medical assignment and the individuality of the player. So if we're going to do some moderate to max effort transformer bar loading, you see the main thing is you can still get that great squat pattern. This is actually on the front squat mechanism, but take a lot of stress off of the scapular and shoulder complex because you can have this fixed position. Okay. But keep in mind, you want more posterior chain work, you switch to more of the hinge or that low bar squat. Now, this is dynamic. Okay. So with this one, this is a 1-1 X tempo, light loaded transformer bar squat, but heavy on the variable load. This is where we add the push system to track the bar velocity. So immediately after this, when we track bar velocity that dictates the variable load, we will get the force plate data to then track and quantify and assign the subsequent volume and intensity of the assigned explosive motion, and be able to track overall volume and number of sets based on that force plate biometric data. All right. Right here, we just have a different view. This is more of what we call a high box. I don't think there's anything wrong with doing high box squats. This is actually set almost at that front squat, goblet squat mechanism. We decided to load the quads on this individual athlete based on the medical assignment. He's still sitting back. It's just more of that high box position to significantly load bar speed in that later week 3 phase of like a speed strength part of the conjugate. So we're still going heavy band loading, just significantly increasing the bar velocity through the push system. Okay. And this one, our tracking was trying to get over 1.5. Now, this is not a favorite for baseball. I'm only showing it because this is the typical standard of what you see on a box squat. Typically, we will take, if they absolutely are not comfortable with the transformer or safety bar, we at least try to get them into like a Duffalo bar. I would prefer safety bar, but a lot of times when we're doing either moderate max effort, especially dynamic loading, if they're just not comfortable and cannot brace the trunk, we will still go that standard Duffalo bar system because at least it's easy to lock in. Now, keep in mind, that's only if they are medically cleared of minimal asymmetries at the top transitional vertebrae of right-left symmetry of trunk and spine motion. And then this is just some standard max effort loading lower body of a Bulgarian squat, max effort loading of the hinge. If we're ever in doubt, we go to the hinge. Typically, once we get that trunk and spine isometric symmetry between left-right rotation, left-right pelvic approximation, and left-right spinal lateral flexion, isometric symmetry, we can at least start to max effort hinge load them. And this is a comfortable action for a lot of baseball players anyway. So if we're in doubt on the system, then we go. Okay, so now let's go back and review what a day 2 might look like on conjugate. Okay, so keep in mind, day 2 is lower body dynamic you see here. The primary exercise is typically a speed box squat, either using that rogue belt squat, the transformer bar, or a safety bar if you don't have a transformer bar, or that specialty Duffalo bar. We're going to try to get into, this is more of like a week 3. If we're going to do a 3-week microcycle of conjugate, by week 3, we're trying to drive towards a tempo of either 1-1X or X1X. 60 seconds rest. We'll either be looking at speed strength of 1.0 meters per second bar velocity or above, or if we're in like week 1, we're going a little bit heavier on the variable load, looking at strength speed, which is about 0.75 meters per second on the bar velocity. So just like we explained earlier, you will do 1 set of 3 or 2 immediately into the force plate data for 1 jump. Rest 60 seconds, do another set immediately into the force plate data. Right from there, after the second set, that's when we get into the explosive choice, which could either be the Proteus, which you guys have seen the video of, the flex line motion, the Kaiser motion, just a basic band explosive motion, or the cable system with the band attached, which is going to be possibility of lower body quantification, which could be like if we're doing a box jump, we'll put the push system on the person. Okay. If we're doing an explosive loaded, we'll put the push system on the device, or just a standard lower body explosive, which could be a depth jump or a seated depth jump. So the tempos could be anywhere, which you saw variations of this: 4-1X, X1X, XXX, X2X, X4X. Okay, the volume obviously varies based on what? The biometric data that we're continuously getting from set to set on the Vlad external force plate data. Okay. So if you think about how this is going to go, we go 2 sets of squat, complex of 2 sets of vertical. After the second set, we hit our explosive. Some of it's going to be quantified extensively like the Proteus. Some of it's going to be modified, quantified like the flex line. Some of it's not going to be quantified at all, like a band jammer or a lower body explosive. Okay. 60 seconds rest, you hit set 3, set 4, next set explosive. So at the end, we're trying to gain about 12 sets of dynamic with the force plate data. If the biometric values either starts to get more asymmetrical or values come down, we cut the volume, possibly 8, set 9. If that data keeps going up and they're driving towards more symmetry, we'll add in more explosive work. So not only quantifying what volume to assign on a Proteus or a band jammer or a depth jump, we're also looking at the quantification of the explosive itself. So we start looking at those strict biometrics. Now we can see nervous system up, go, nervous system suppress, back off, and make sure we're never going to be getting in that overtrained state. Okay. Now keep in mind, let's contrast that now. Let's pull up that day 4 max effort lower. This is the standards, what you see in research. We're going to go a loaded double leg squat or hinge or single leg squat, immediately followed by either a quantified or a non-quantified explosive motion. But how are we going to track the PAP? The force plate data that goes from the load, immediately get the force plate, go right into the explosive. So realistically, the conjugate is just like you see in literature. You're loading lower body, subsequently hitting the explosive, taking a rest and hitting it again. But as opposed to trying to guess the PAP just because literature says it, we are quantifying PAP and modifying the volume and intensity and possibility of the exercise choice based on that data. Because I've seen it where we're expecting nervous system to be somewhat down, but maybe 85%. So we'd say, okay, let's go a hinge and a depth jump. Then we're getting the force plate data. We see that biometric way up. We'll immediately switch the depth jump into the Proteus, now start tracking right-left symmetry because the nervous system was better than expected. This is what I call unplanned periodization. Even though we plan the conjugate, we're unplanning and basing volume and intensity based off biometrics. Okay, so now we've reviewed what this looks like in terms of the actual data. This is the force plate here. So it's simple. 1 to 2 jumps is not going to interrupt the flow of your weight room. You see the computers right there off to the side. And as they're going, we're getting this data. Now, we're not going to be able to read every single biometric we're looking at that you see here. Okay, it's extensive. But some of the key points is, what does peak power look like set to set based off the initial medical variance right before the session, and what the beginning eval look like? And what does the asymmetry baseline look like? If we see this biometric go up, we're adding volume intensity. We see it start to go down from set to set, we're going to cut it. If we start to see more symmetry, we're going more. We start to see more asymmetry, we're cutting less. So even on whether it's a dynamic complex or a max effort complex, we're basing everything based off this data. Now, my physical therapists love this because you know how physical therapists are. Every medical person here is probably saying, that's great. We've used all these external force plates in our system periodically as we're rehabbing. But now we're forcing them to even go in during the preset treatment right before the training and tracking force plate data to quantify and stabilize the medical work, but now have a marker for how we're going to compare it as we're training to get that PAP effect overall. Okay. So, and keep in mind, every strength coach is probably thinking, hey, this sounds great, but I got a loaded weight room. What am I going to do? Look at peak power, look at asymmetry quick. Everything else goes up into the cloud. We've already put in the cloud on the digital workout what the complex was assigned. If we now take that load, put it into their account, we know the PAP effect with all the biometrics based on how we did. But how are you going to instantaneously do it in the live weight room? Look at peak power, look at overall asymmetry. And just to review too, this is the Proteus here. There's a basic diagonal high rotation, but this is what the Proteus looks like. So what we'll require athletes to do is right before they hit the assigned Proteus, if it's assigned on that day, quick screenshot of the phone, their account comes up. We have the assigned workout. You press a button. After they do it, and while they're doing it, you're going to see those markers side to side, just making sure that you're in the proper range of motion. Immediately after the set, not only does this go into their online account, we can see this live. So yes, we're quantifying bar velocity. We're quantifying the PAP effect right before this, but now we're quantifying the acceleration, deceleration, and most importantly, we're looking at those symmetry markers of left to right based on any motion we assigned on the Proteus. Okay, that's how we use it. Now, we can also do the push system, as we talked about, of putting the push system on the body. Okay, so we will do box jumps. There's nothing wrong with doing box jumps. You know, baseball players need general loaded or horizontal power. That's why we use the open-ended trap bars, by the way, because if we're going to go a load into an explosive, we are tracking the body velocity by attaching the push system in the belt on the person. This is a basic jump mat. We'll still do duck jumps. As you see on that one, the athlete did the quantification of assisting the force down, releasing the bands, and looking at ground contact, or RSI. The high trainers we talked about, we don't use this as a treadmill. We use this as a weightlifting tool. This one is good because we might need lower body horizontal power endurance as that number 2 on this PAP complex. So imagine we do a max effort loaded Bulgarian squat, immediately get the force plate data, then assign a 6 or 8 second high trainer sprint, which if you look, it's not a running motion. It's a horizontal lower body that now is tracking right-left symmetry of force production, peak power, and average power. The main thing we're looking at, same kind of quantification. Is the power going up? Is the symmetry either being maintained or driving towards better symmetry? That is additional quantification we can do that's going to map right to that PAP quantification we talked about. And then we're just going to kind of let the video run here. This is some other things that could be assigned. That's general. We've all seen this before. Standard Vertimax jumps, Vertimax depth jumps, any type of non-quantified metric. Now, if we're going to go into a cable, we just use the rack attached because we put these attachments where I can variable load it. So whether we're doing a pull, doing a single arm pull, doing a double arm pull, doing a chop or lift pattern, we'll do it. Now we're just getting into basic auxiliary, okay? When we get into auxiliary, this can't be quantified, but as you saw in every conjugate phase that we put up there, the auxiliary motions are absolutely essential, okay? If we're gonna do an explosive press, fine. We're gonna keep it simple, possibly simplistic quantified on a flex line or a Kaiser. We could just do something as simple as an auxiliary variable loaded band pull. We do get into some dynamic work on even on the field. So if you saw on that one conjugate, we're looking at dynamic rows, dynamic triceps. It could either be individual with an isometric one tempo, or it can just be continuous like you see here in slow motion. But this is good work to put on an upper body dynamic day for an overhead athlete, or just looking at really focusing on that pelvic split position of our elbow extensor variable loaded work. Here's some basic auxiliary patterns, what you're going to see with some posterior chain, whether you're going to do basic floor glute ham, basic angle back extension with variable load possibility, or full glute ham raise. You see here some single leg hinge auxiliary work. We're looking at some assist, resist to some diagonal patterns like a lateral lunge. And then we get into trunk and spine. So I talked a lot about what we do trunk and spine to drive towards symmetry. This is the medical system. This here is a Kiro core vest that we use because without holding and looking at the external variable of trying to hold a position, we can attach it to each link system on the vest, looking at isolation of slow motion, pelvic approximation, and or trunk rotation. This is basically what we call an auxiliary corrective work, where you see the Kiro core vest being used, the quantification of the air resistance, but notice how it's on one side of the vest. So subconsciously, whether we're doing a slow sled march or an explosive work, what is it working isometrically? Spinal rotation during either dynamic or slow hip extension, strength endurance exercises. That's what I call the integrated trunk. So we got to train trunk isometrically. We also have to integrate it through things like the Kiro core. Okay. Now this kind of summarizes everything that I just talked about during the video. The medical evaluation's got to be prior to the GPP phase. When we assign a GPP, it's typically machine-based segmental strengthening. And those corrective exercises I showed during the rest period is based off symmetry, trying to achieve symmetry. We're going to evaluate every joint in the body, all the joints of the toes, forefoot, rear foot, and forefoot, rear foot articulation, all the ankle motions, including rotation, knee motion, not just flexion extension, but knee rotation, looking at every motion of the hip, the pelvis, all the spinal column, specifically the transitional vertebrae of flex, extend, lateral flex, left, right, rotate, left, right. And then the obvious, which is going to be the shoulder joint, the scapular joint, and on down into the wrist, elbow, and up into the neck. So everything is based off of range of motion, quality of the range of motion, stability at the end range of motion, and then the performance strength conditioning biometrics, which is dynamic stability at the end range of motion. Okay. And that's when we're starting to get the baselines of the force plate, the Proteus, and things like that. And then we get into like the continuation. This is where the medical staff is essential to me to start to look at what type of specialty bar assignments that's going to map each player. The explosive assignments, not just based on the athlete's goal or what the team tells us they need, but driving towards body alignment and maintaining it in the advanced phases, or just a squat versus a hinge. I have no problem with a physical therapy report saying, we know the athlete loves a squat, but his imbalance is in the hinge. Let's map that with force plate, Proteus, flex line, and see where we go in terms of driving towards more symmetry. And once we get the posterior chain, then let's move into a safe squat. Okay. And then this is just a good summary of everything I've just talked about of what are we looking at from medical? How are we integrating into the biometrics? What are we doing beginning of off season, beginning of the transition from phase to phase, and how do we quantify it overall? Okay. And then if we just want to really drive towards, okay, the conjugate phase worked, we're quantifying it. We definitely are not in an overtrained state because we are consistently looking at the metrics live, pre-post. What do? Okay, now this is just one basic week 3 sample of an ascending descending phase where day 1, you kind of ascend up from light power, moderate power, heavy power, max. So it's almost like a 1, 2, 3, 4, take a really, really good rest, do some corrective work. Then hit your auxiliary, which is some pressing and some elbow extensor work. The ascending lower, same kind of concept. You have unloaded, light loaded, heavy loaded, and then just max effort work. So power, heavy power Bulgarian. Now keep in mind that this is just what a standard would look like. How would we then do it? We would still put that force plate data before every 4-set complex and after the 4-set complex. And then start to look at, well, as opposed to hyper single arm row, we might be doing a Proteus single arm row. As opposed to a speed belt squat, we might be doing a hinge. As opposed to a box jump, we might be doing some air resisted or some band jammer work. Okay. And then day 3, day 4 is descending down. Now you have your max effort to heavy load, light load, unload. 1, 2, 3, 4, get some good work. But still, we're on this, we're still quantifying that effect of force plate data that we talked about throughout. Okay. So I think I'm right on time, aren't I, Frank? You wanted me to leave a few minutes left for questions, I believe. So let's open up the questions now. And if you want me to replay any of the videos or anything like that, we can go through it.
Thank you, Pete. Any questions? For someone to come in the box here, and you were on time. Yes, thank you. Question: only testing vertical jump on the force plates.
When we do all of our force plate metrics during the medical evaluations and successive everyday medical treatments, we're testing as much as we can possibly test, given our time constraints. If we're doing some baseline work before a live weight room session, of course, we're doing a lot more than just vertical jump. If we're taking those external force plates and putting it into a live weight room even with a small group where we've got to constantly just be measuring the PAP effect, we typically just stick to the vertical jump because it's going to show us how much PAP data. Now, if we decide to get real effective, and we know that almost everybody's going to be on some band jammer rotation, we might get a little crazy with it, get the feet on force plates as we're going through explosive motions. But as I showed, we're mainly looking at the neurological effect of the dynamic squat hinge or the max effort squat hinge. Just getting the PAP data, and right before the explosive motion, I don't think you need to be standing on force plate. So sorry for the long answer to your question. The answer to the baseline simple answer is we'll do a lot more before the session. We'll keep it simple during the session so we can get the biometrics and keep the flow going of the session.
Another question: most of the ball players that you're working with, Pete, are they doing their skill work after your sessions or prior to hitting, throwing?
I mean, when we see trends, I mean, it's really going to be what some of the teams assign, and we get data from our high school baseball players, our academy elite baseball players, minor league, major league strength coaches in terms of what their preference is. Then obviously we have the preference of the athlete. Then we have our recommendations. Our standard recommendation is get the performance work done early in the off season. And then as we start getting later in the off season, where the performance takes some measurables and takes a lot more of an important effect, we might have them do their hitting and then come and train after like a 2-hour layoff. Well, keep in mind, that's also another reason why we love things like the force plate and the Proteus, is because we can quantify the effect if they did hit prior. Now, and keep in mind though, they have to look at the hitting or pitching biometrics. We definitely don't really want that to be after a conjugate lower. You know what I mean?
Mm-hmm.
We'll make sure that we map our days around when they're with their hitting coach, pitching coach, and looking at all the baseball specific biometrics. So it's really general thumb, like I said, but we also have to make sure we integrate within the teams that we're working with that have, the information flow when we're training a player, as well as just the goal of the player themselves.
Great answer. Another question: do you use percentages for primary lifts or use VBT to guide loads?
Really both. I mean, the standard is when we enter something like a conjugate phase, we are looking at a 50% bar load to initiate the baseline. But we're going to start to add in the band, the chain tension. And then what we see is when the biometrics of the velocity-based push system is going up, we don't add more weight, we add more variable load. Force plate data, add more variable load. we start getting into those really hard explosive metrics like the Proteus, we add more variable load. But we still try to stay consistent with this is the strength speed phase. We're assigning approximately 0.75 meters per second on the transformer bar squat. If we start to see it down, we add a little bit less variable load. If it starts to get up into 0.9, 0.95, we add more variable load. We try to keep the bar load right at 50%. And then start to load a little bit more bar load each time, or just continuously, which is my preference, add more variable load, just trying to gain more bar speed from week to week.
Another question. Have you found good results with the PAP transfer from a lower movement to an upper rotational, or do you use similar patterns to achieve desired goals, upper body movement / upper body power development?
That's a great question. And to be quite frank with you, that's almost the exact reason why we insisted, and I worked hard to work it into my budget, of getting external force plates and things like the Proteus and the flex line and all that, and making sure our racks had those adjustable jammer arms, because I wanted to see it. And we are seeing the trend. And we actually did an entire research study with Nova Southeastern University, and we're going to continue to do it with elite level athletes, whether it's baseball, boxing, football, where we're starting to drive towards different trends of what's working with each individual athlete. What I'm saying is, let's say that we do a hinge loaded. The typical is, let's do a box jump. We're seeing hinge into an explosive rotation that might be half kneeling, taking a lot of the lower body part out of the energy transfer. We're looking at pelvic torque. And then we're looking at a max effort loaded single arm row complex with things like a depth jump. So even though we're going outside the variances, what you see in literature, what we're trying to do is look at how effective this quantification is and driving that data back into research to try to go outside the norms. So a long answer to your question is, we'll do both. But my ultimate goal is the trends we're seeing of what type of max effort loading produces which type of pelvic torque on these baseball specific things that's unique to each individual. And once we get the data, that's how we're driving towards the later phases of conjugate, or really specifying that ascending descending.
The person who asked the question put an example, like pairing the jammer with a medicine ball, or the Proteus with swinging a bat.
I mean, we haven't gotten into that too much. You know, we try to separate the actual specifics on, but I would have no problem doing this. And a lot of our players want to do this as we start getting into January and February. The post-activation potentiation based on literature could last 4 to 10 minutes. We know that. Now, we're not going to sit around for 10 minutes in a weight room and have our weight room sessions 3 hours long. But some people do want to do not necessarily a loaded conjugate, but piecing together the concept of how to drive PAP into rotation. And then within 10, 15 minutes, immediately after that portion of the workout, looking at the metrics in swinging a bat and exit velocity and things like that. Now, I probably wouldn't have the guts to do it with a pitcher just yet, but I have no problem with the hitters that want to get on the Rapsodo and start looking at exit velocity based on post-activation potentiation. And it's interesting you ask, because everybody that trains with us right now that's a hitter has asked that exact question. They want to see it. And I'm interested in seeing it as well. I think that's kind of the next phase. You know, the good thing for us is we got the hitting system in an indoor cage right next to our weight room. We can easily just transfer down, give it a good 10, 15 minutes and see if that PAP is still up. And I have no problem even bringing the force plate down and just looking at what happened between the weight room, post weight room when we're looking at the Rapsodo or something. Did that answer your question? I hope I answered that adequately.
Yeah, for sure. We can have you back next year to tell us how the results came out.
Yeah.
Swinging in the cage there. Well, very good. Outstanding presentation. We really appreciate your time and expertise, and thank you so much.